In this chapter, let's study the properties of gases. Avogadro's law or Avogadro-Ampere's hypothesis is an experimental gas law relating the volume of a gas to the amount of substance of gas. Avogadro's law states that equal volumes of all gases, at the same temperature and pressure, have the same number of molecules. For a given mass of an ideal gas, the volume and amount, number of particles, of the gas are directly proportional if the temperature and pressure are constant. For example, 2 moles hydrogen reacts with 1 mole oxygen to form 2 moles water. So, if the temperature and the pressure remain unchanged, and the reactants and product are all gases, 2 liter hydrogen and 1 liter oxygen react to form 2 liter water vapor. There is a relationship between pressure and volume in a gas at constant temperature. Please look at the example below. For a fixed amount of matter and constant temperature, the pressure of a gas tends to decrease as the volume of the container increases. However, the product of pressure and volume is roughly a constant for all gases when pressure is low. The relationship between pressure and volume in a gas at constant temperature is the Boyle's law. It states that the absolute pressure exerted by a given mass of an ideal gas is inversely proportional to the volume it occupies, if the temperature and amount of gas remain unchanged within a closed system. Gases tend to expand when heated. Charles' law is an experimental law which states that, when the pressure on a gas is held constant, the absolute temperature and the volume will be in direct proportion. The temperature where volume reduces to zero is defined to be absolute zero. It is the 0 point of absolute temperature. The unit of absolute temperature is Kelvin. So, absolute zero is 0 Kelvin. Gay-Lussac's law is the relationship between pressure and temperature of a gas at constant volume. It states that the pressure of a gas of fixed mass and fixed volume is directly proportional to the gas's absolute temperature. We can combine the Avogadro's law, Boyle's law, Charles' law and Gay-Lussac's law. They lead to a relation that the product of pressure and volume is proportional to the product of amount and temperature. The proportionality coefficient is R. Here, I show you the volumes of 1 mole gases at identical temperature and pressure. It is clear that the volumes are almost identical. So, the proportionality coefficients of them are also identical. R is called the ideal gas constant. The ideal gas law is a combination of the empirical Boyle's law, Charles' law, Avogadro's law, and Gay-Lussac's law. The hypothetical gases complying the ideal gas law are ideal gases. There is an alternative form of the ideal gas law, which is also frequently used. Please remember that the number of particles is the product of its amount in mole and Avogadro constant. The ideal gas constant is product of Boltzmann constant and Avogadro constant. The relations among the laws are summarized in this figure. Please pause here to check all of them. A mixture of ideal gases is still an ideal gas. Besides the total pressure, we can also define the partial pressure of each component. The partial pressure is the hypothetical pressure of a component if it alone occupies the entire volume of the original mixture at the same temperature. Pay attention that the partial pressure cannot be measured directly. The partial pressure of a component is calculated according to the ideal gas law. The relation between the partial pressures of components and the total pressure is the Dalton's law. It states that the total pressure of a gas mixture is equal to the sum of the partial pressures of the individual components. The Dalton's law can be derived from the ideal gas law and the definition of partial pressure. For example, the total pressure of air is equal to the sum of the partial pressures of nitrogen, oxygen, argon, water vapor, carbon dioxide, etc.